Welcome to The Explainer. Today, we're going to tackle a question that sounds simple, but is actually surprisingly tricky. How do you find the single most common value when your data isn't a neat list, but is all chunked together in groups? It's a really common problem in stats, and the solution? Well, it's pretty clever.
So just imagine you've got this data from a survey, right? This table here shows family sizes in a neighborhood. You can see right away that the group 3 to 5 people is the most common, but what if you need to be more specific? What's the single most likely family size? Is it 3? Is it 4? Maybe 5? The table itself doesn't give us that exact number.
And you can't just guess or pick the middle number. The moment your data is organized into ranges like this, finding a precise average becomes this really interesting puzzle.
So in this explainer, we're going to walk through the solution, step by step. We'll unlock the methods for finding both the mode and the median in grouped data.
Okay, first up, let's talk about pinpointing the mode. All mode really means is the most popular, most frequently occurring value in any set of data.
You know, for a simple list of numbers like this one, finding the mode is a piece of cake. You literally just look for the number that pops up the most. In this list of scores, the number 2 shows up 3 times, more than anything else. So boom, 2 is the mode. Easy enough. But with our family size data, we can't see the individual numbers. All we can see is the most popular range, and we have a name for that, the modal class. The real mode, that single number we're looking for, is hiding somewhere inside that group.
So how in the world do we find it? Well, statisticians came up with this formula to estimate it. Now, I know it looks a little intimidating, but the logic behind it is actually pretty cool. It basically starts at the low end of the most popular group, and then it inches its way into that group based on the gravitational pull of the neighboring groups. Let's break down what each of those letters means.
So here are all the pieces of our puzzle. And as you can see, each variable is actually pretty straightforward. It really just boils down to the frequency of our main group, the modal class, and the frequencies of the groups right before and right after it.
Let's actually use it now. First things first, we got to find our modal class. Looking back at our family size table, the 3 to 5 group has the highest frequency, which is 8. So that's our modal class. Step 1, done.
Okay, next up, we just pull the numbers we need straight from the table. The lower limit, L, is 3. The class size, H, is 2, because the groups span 2 numbers, like 3 to 5. The frequency of the modal class itself, F1, is 8. And then the frequencies of the class before and the class after are 7 and 2.
And now for the satisfying part. We just take all those numbers and plug them right into the formula. From here on out, it's just simple arithmetic.
And what we get is about 3.286. So our best estimate for the single most common family size isn't a whole number at all. It's a value just a little bit past 3, which makes sense since the group before it was also pretty popular.
So that's the mode, the most popular value. But now let's find a totally different kind of center, the median. This is the true middle point of our data. And for this, we're going to switch to a new example using student test scores.
Think of the median as the 50-yard line of your data. Exactly half the values are below it, and the other half are above it. It's the physical center of the entire data set.
All right, here's our new table with student marks. Now, to find the median in grouped data like this, the secret weapon is this third column, the cumulative frequency. It's really just a running total. It shows us how many students have scored up to the top of each range.
And hey, look familiar? Just like the mode, the median for grouped data has its own special formula, and you can see it has a pretty similar structure to the one we just used.
Now, even though it looks similar, the variables mean slightly different things here, all tailored to find that exact middle point. So N is our total number of students, and CF, well, CF is the cumulative frequency of the class that comes right before the median class. That's a key detail. So first, we have to find out where the middle student even is. Let's say we have 53 students in total. The middle point, or N divided by 2, is 26.5. So we're looking for the 26.5 student. We just scan down our cumulative frequency column, and the 60/70 class is the first one where the total, 29, goes past that 26.5 mark. That makes 60/70 our median class. So now we just grab our variables again. The lower limit, L, is 60. The frequency of this particular class, F, is 7, and this is the important part. The cumulative frequency, CF, that we use in the formula is the one from the class before our median class. So in this case, it's 22.
We plug all of those values into our formula, run the numbers, and we get a median score of 66.4. What this means is we can estimate that about half the students scored lower than 66.4 and the other half scored higher. We found the true center line of the test scores.
So there you have it, 2 really powerful tools for finding the center of your data. But this brings up a big question. Which one should you use and when?
Well, it really all depends on the story you're trying to tell. The mode is your go-to when you want to know what's most common, what's in the highest demand. The median, on the other hand, gives you the true halfway point, and it's fantastic because it isn't easily thrown off by a few really high or really low numbers.
And what's really amazing is that these 2 measures we just calculated, the mode and the median, are often connected to a third measure of center, the mean, or what we usually think of as the average. For a lot of data sets, they're linked by this really elegant formula. It's just a great reminder that in statistics, these different ways of looking at the center are all related to each other.
And this leaves us with one last critical question. If the mode, the median, and the mean can all point to different centers and tell different stories from the exact same set of data, which one is the truth? Well, the reality is none of them is the truth. They're just tools, and the right tool always depends entirely on the question you're asking. Knowing which one to use, that's the real key to understanding what your data is telling you.